Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Hello dear students, I hope you're all doing well. So inshallah we are going to go through module 4, lesson 2. Okay, that's from the Inspire Chemistry book, and the title is Quantum Theory and the Atom. Okay, so before we go deep into the lesson, I'd like just to start and review some of the basic physics knowledge that you already gained. So our skin becomes hot under the sun because we absorb the energy that is in the light. In other words, light is energy. Do you think this statement is true or false? So, as many of you, I believe, answered, the answer is true. Yes, light is energy. Now, light has both wave-like and particles or energy-like nature. يعني الضوء يمكن نمثله بشكل الموجة أو إنه عنده طاقة أو إنه الجسيمات فيها طاقة. Okay, it's like a wave and also like a particle. Can we say both about light? The answer is true. Okay, this is from previous knowledge probably in science and also from section 1. Okay, so we can go now to the keywords of this lesson. These are some of the important keywords which you will see throughout the videos and also in the book. So matter, المادة, okay, very easy. If I say stuff, I mean things, all right? Substance. So substance is a material or an item, or مادة. It's like matter, okay? So substance is similar to matter. Atom, ذرة. Model is like a prototype or نموذج, okay? Particles. So particles. So if I say the word particles, it means small things, okay? Or small things, yeah, or tiny objects, okay? For example, particles can be atoms, can be protons, can be electrons, can be neutrons, anything. If I say the word orbit, orbit means a circular path. So orbit, مدار دائري. So anything that has a circular path is called an orbit, like the orbit of the Earth around the sun. All right? Okay. So you know this from physics and from science. This is a wave. This is the wavelength, الطول الموجي. Okay. So if we look at the wavelengths of different colors, okay, what you are going to notice is the following. The wavelength here is different from here, is different from here, is different from the one down here, is different from the one down here, okay? So as we go down, the wavelength is increasing, right? See? 400 nanometers, 425, 470, and so on, as we go down, okay? So this has the lowest wavelength, and this has the highest wavelength. So different colors or different parts of light have different wavelengths. Now let's think together. Is UV light, الأشعة فوق البنفسجية, safe or dangerous? What do you think? And why? Based on your answer, how can you explain if it's dangerous or not? So of course UV light is dangerous. انتوا تعرفون إنه أشعة فوق البنفسجية ضارة, صح? So it is dangerous. But why is it dangerous? Okay? So the reason for that is that different wavelengths have different energies. So if you remember here, these parts of light have different wavelengths. So because they have different wavelengths, they have different energies. And the relationship between wavelength and energy is the following. It's an inverse relationship, علاقة عكسية. If you have a lower wavelength, يعني طول موجي قليل, it means you have a high energy, طاقتك عالية. والعكس صحيح. So if we see electromagnetic spectrum here, the visible light اللي هو الضوء المرئي اللي نعرفه اللي هو ضوء الشمس المكون من ألوان الطيف المرئي, you can see that the wavelength is very high. So the wavelength is very high, it means the energy is low. So energy is low. لأن the wavelength is very high, between 700 and 400. Now here, it is between 290 and 400 only. الالترافيوليت. الطول الموجي قليل. Lower wavelength. So what about energy? High energy. So because it has high energy, that's why it's dangerous for our skin, because it has a very high energy. Okay? And you know this from your science course, the continuous spectrum, الطيف المتصل اللي هو ضوء الشمس. If we pass the sunlight through a prism, المنشور, it will dissociate, okay, or it will break down into the rainbow, yeah, the 7 parts of light, which you already know. نشوفها مثلا بعد المطر، صح؟ So keep that in your mind. We call this the continuous spectrum. Why? Because all the colors are connected together. There is no black parts in the spectrum. Okay? So, to get the emission spectrum of an element, you must heat it up. Okay? So, what is the emission spectrum of an element, or the atomic spectrum of an element? What is that? Okay? So, do you remember this from the previous video, the introduction video? So, if we burn an element, it will produce some light. Okay? Do you see the light? This is red light, orange light, gray light, light blue or pale blue light. But this light, if we pass it, for example, here we have metals. Imagine I put hydrogen and I burned hydrogen down. It will produce a violet color or a purple color. Okay? If I pass it by a prism al-manshur, then what's going to happen is that it's going to break down into 4 colors. Okay? Or 4 types of colors. And these colors are purple, blue, light blue, and red, as you can see here. Okay? So this is like the fingerprint of hydrogen. هذه نفس بصمة الهيدروجين. إذا أخذنا الضوء وحطيناه في منشور راح ينقسم إلى ألوان أو أطوال موجية معينة. وهاي الأطوال الموجية عندها هاي اللون، هاي الألوان اللي نقدر نشوفها إحنا. Okay? So, as I was saying, what is the relationship between this and what we are studying in this module? So this part is actually from lesson 1, اللي هو إثرائي, but it is very important for me to show it to you because it will help explain where are the atomic models coming from. Okay, so again, if you burn anything and you pass it by a prism, okay, this light here will be made of different types of light. So الهيدروجين اللون اللي يطلع يتكون actually من 4 ألوان. Okay, so it's like a fingerprint, كأنه بصمة للهيدروجين. Okay, so these are the wavelengths. Okay, now this is for hydrogen. This is called the emission spectrum or the atomic spectrum of elements. كل ذرة أو كل عنصر عنده emission spectrum مختلف، طيف إشعاعي مختلف أو طيف منبعث. Okay, so this is the visible spectrum اللي هو الطيف المرئي لضوء الشمس، continuous، ما في أي black parts in it. Okay, now this is for helium. Do you know the helium gas? Do you see these lights here, these bands, these lines? If we burn helium, it will produce a color. If we put it in a prism, it will produce these lines. See, different lines. This is iron. تعرفون الحديد؟ iron الحديد. إذا حرقنا الايرون بيتوهج. إذا خذينا هذا الضوء من الايرون وحطيناه في prism, this is what we are going to see. A lot of colors. But notice that there are black parts here, black. Do you see these black parts? So that's why this is called the emission spectrum, not continuous. It's not continuous. So the main question now, my dear students, is the following. We have different elements, right? And they have different emission spectrum. Why is that? So why do elements have different lights when we burn them? And why do they have different atomic spectrum or spectra when we pass the light through the prism? عندهم بصمات مختلفة, right? So it has to do with the main question of the lesson. So why does every element produce a unique special atomic emission spectrum? You have to think about this, okay? So it has to do with the atomic models and the electrons around the atom, okay? So it has to do with the atomic models and the electrons around the atom, and this is why what we are going to explain. We are going to try and explain why does hydrogen have these lines? How can we explain them? Why these lines only? And why 4? Why not continuous like the light? Okay? It takes us to our second part of the lesson, and we are going to explain the keywords in it. We already talked about the first 3. So when I say the word ground state, it means low energy, كأنه الجراوند فلور في الإليفيتور. When I see excited state, so excited, yay, okay? It's like you are very excited, very energetic, you have a lot of energy. So it means high energy, okay? Now the word quantum means the minimum amount of energy gained or lost by an atom, okay? So just keep it in your mind. Quantum means or comes from the word quantity, اللي هي الكمية, okay? And quantum means الكم. So it just tells you how much is the amount of energy gained by an atom or lost by an atom. How much is it? Okay? Now the word photon, which you might find in your book as well, photon means a particle of light. جسيم الضوء. So again, these parts are in the first lesson, but it's good for you to know so that you can understand the full picture, okay? So it's the smallest amount of energy possible. So a photon is the smallest amount of energy possible that is in light, okay? يعني ما في أصغر من الفوتون. That's what I'm trying to say, okay? Now we are going to go to the first model of the atom, and that is Bohr's model, okay? Now, what did Bohr say about the atom? He said that the nucleus is in the middle, okay? And around it, there are orbits, okay? مسارات دائرية, okay? And the electrons are in these orbits, okay? So the electrons are in these orbits. They can be in these orbits. It's similar to our solar system, where the nucleus is the sun and the electrons are the planets. And the electrons are moving in a circular path, okay? Electrons cannot be between orbits. They can only be inside the orbits. This is a summary of Bohr's model. It's the simplest summary of Bohr's model. Now I'm going to leave this link for you down in the description. It's an EduShare link. It's very, very nice and has some videos that explain more about Bohr's model of the atom. So Bohr is a scientist. So Bohr, الاسم Niels Bohr, is a scientist from Denmark. Okay? He said that the nucleus is positive and the electrons are around the nucleus and they are moving in a circular path. Okay? And he also said the following. So this is the figure that you have in your book. It shows similar atoms, but one is in the ground state and one is in the excited state. So what does that mean? So as you can see here, the electron is in the first orbit, right? So because it's in the first orbit, like the ground floor, so it has the lowest energy. So we call it the ground state. So lowest energy. Now imagine if the electron was here and then jumped to the second orbit. So because it went higher, we say it's in the excited state, meaning higher energy. So electrons can move between orbits. يقدرون يتحركون ما بين المدارات، لكن مش بينها، بس ما بين المدارات. Okay. So the ground state, in the ground state, the electron is associated with the lowest energy level, and when an atom is in the excited state, the electron is associated with the higher energy level. Okay? As you can see here, if an electron was moving and it absorbs energy, remember photon? Energy. So إذا امتصت energy, it means it has higher energy. So it can go and live upstairs. So it goes up. Okay? Like you see from here to here, it goes up. Right? So this is Bohr's model of the hydrogen atom. Bohr said that the nucleus is in the middle, okay? And you have energy levels, or you have orbits where the electron can exist. طوابق. The first, second, third, fourth, and so on. Okay? And as you keep going, the radius is increasing and the energy level is increasing. And this is the relative energy. So E1, imagine E1 is 100 joules, for example, then E2 is going to be 4 times 100, so it's 400. And E3, which is number 3 here, is going to be 900, اللي هي 9 ضرب 100, and so on. هاي الأرقام طبعا تخيلية, okay? بس أشرح لكم relative energy. يعني level 2 عندها 4 أضعاف الانرجي حق level 1. level 3 9 أضعاف energy حق level 1, and so on. And n equals 1, these are the levels or the orbits اللي نتكلم عنها هني، اللي هي المسارات الدائرية اللي شرحناها قبل شوي. So that is Bohr's model of the hydrogen atom. Now, what is this model going to help us with? Like, why did he create a model like this? We are going to answer that question after this activity, okay? So, let's read this question. The model of the atom that has electron going around the nucleus in an orbit, يعني عندك النيوكليوس هني وعندك الإلكترون يلف عليها, is called which model of the atom? It's called Bohr's model, right? Which we have here. So this is Bohr's model of the atom اللي كنا نشرحها قبل شوي. Now, which atom is in the ground state? Image A or image B? So ground state means lowest energy. يعني أقرب شيء للنواة. يعني أصغر مدار دائري أو الأقرب. So it's going to be image A. Now, which atom is in the excited state? It's going to be atom B, because the electron is far away from the nucleus, من النواة. Okay? It has higher energy. Alright. So now let's mix what we studied at the beginning. Remember the hydrogen emission spectrum, the 4 lines, and mix it with Bohr's model. And let's see what we are going to get, okay? So remember our question, why is the emission spectrum of hydrogen not continuous? Why do we have only 4 lines here? What's the reason for that? So Niels Bohr, Bohr's model explains this. So Bohr's model of the atom explains this question. Why is the emission spectrum of hydrogen not continuous, only like 4 lines? So, as you can see, this is Bohr's model, guys, right? So you have the nucleus and you have your energy levels, اللي هي orbits, 1, 2, 3, 4. You can draw as many as you want, okay? So imagine you have an electron in the 3rd energy level. Can you see n equals 3? So 1, 2, 3. And it moves to the 2nd level. So which one has higher energy, the third or the second level? The third level. So if you want to go down, you need to lose some energy, right? So you will lose energy. You will lose energy. So the energy that you lose, energy is light. صح ولا لا? So because you lose a little bit of energy, we are going to see a red light here. And this red light is the red light that you see down here. Can you see that? Now imagine the electron is in level 4. Okay? And it goes to level 2. So from 4 to 2, you lose more energy than when you go from 3 to 2. صح ولا لا? And this color that you see here, because you lose energy, so we see this energy as light. This is the color that is produced. Same thing, if you go from level 5 to level 2, you lose more energy, and this is the color that we see here. And if you go from level 6 to level 2, you lose energy, and we see it as light, and this is the color that we see. So احنا عشان نشرح هاي الخطوط من وين جاية استخدمنا هذا الموديل of the atom اللي هو بورز موديل اللي يقول لك ان هاي الالوان جاية من الانرجي من الطاقة اللي تفقدها الالكترونات لما تنزل من مستوى عالي لمستوى منخفض. Okay? So before we go, this picture is very important. دايما تيجي في الامتحانات. Okay? So this is the visible series. It's called Balmer series. Okay? هاي visible لأن نقدر نشوفها. طبعا في أشعة ثانية ما نقدر نشوفها. Like the ultraviolet series. See, more energy is lost when you go to level 1. From 7 to 1, 6 to 1 and so on. And infrared series اللي هي الأشعة تحت الحمراء. It's called passion or passion. Okay? So when you go from level 7 to level 3 and 6 to 3 and so on. طبعا هاي الانرجي we can't see this one and this one. We can only see the visible series, which is shown in here. Okay? كيف نقدر نمثل هاي الصورة بطريقة ثانية? How can we do that? So if your electron is in level 3 and it goes to level 2, energy level 2, you lose energy, okay? And that's the light that we see. If you are in level 4 and you go to level 2, that's the green, okay? And so on. You go from level 5 to level 2, you lose energy, and when you lose energy, you actually emit a light or that has the color blue. And when you go from level 6 to level 2, لما الإلكترون يفقد الطاقة اللي كانت عنده وينزل للليفل 2، هاي الطاقة احنا نشوفها كضوء. And that's the violet color. Okay? So لما نروح من ليفل عالي لليفل أقل نفقد energy، وهاي الانرجي نشوفها كضوء. Okay? Depending from where you go to where you go, you will produce different colors. Okay? And that's the explanation of the atomic spectrum of hydrogen. We use Bohr's model to explain the atomic spectrum of hydrogen. Okay? But is Bohr's model correct for every type of atom? No. There are some limitation of Bohr's model. Bohr's model is very old. There are newer models, like a car. You can have a car in the 1920s and a car in 2023. Totally different, right? So, from this paragraph, we can find three main limitations of Bohr's model. You have this in your book. So, Bohr's model, very important, explained hydrogen observed spectral lines. اللي هي هاي اللاينز اللي كنا نشوفها. Okay? However, the model failed to explain the spectrum of any other element. So that's limitation number one, التحدي الأول. إنه ما قدر يفسر ال emission spectrum of other elements. It works only for hydrogen. So Bohr's model works only for hydrogen. Also, Bohr's model did not fully account for the chemical behavior of atoms. ما أخذ الخصائص الكيميائية للذرات، ما أخذها في عين الحسبان. Okay? So Bohr's model idea of quantized energy levels laid the groundwork for atomic models to come. Quantized energy means that the electrons can be only at certain levels of energy. Okay? They can't be in between. That's the meaning of that. Later experiments demonstrated that the Bohr model was fundamentally incorrect. So there are some wrong things with Bohr's model. For example, the movement of electrons in an atom are not completely understood. So that's number 3. Meaning electrons, they don't go in a circular path. يعني مش بهاي البساطة. Okay? So evidence shows that electrons do not move around the nucleus in circular orbits. So الإلكترونات ما تلف حول النواة في مسارات دائرية. These are the limitations of Bohr's model. Okay? So these are the 3 limitations of Bohr's model. Right? So now let's think together, guys. If Bohr's model has some mistakes, then where are the electrons really? So where are they? They are not around in circles, but where are they exactly? That's the most important question to ask, okay? Now that takes us to the quantum mechanical model, okay? So this is Bohr's model. You lose energy, you will go down. You get energy, you will go up, okay? So الأسهم الحمراء هاي هي الانرجي. If you lose energy, you go down. If you get energy, you go up. Now, this is a newer model. It's called de Broglie's model. As you can see, the electrons are moving around the nucleus, لكن they are moving as a wave. So it's like a wave, صح? Can you see here? It's like a wave. So it's not just in a circular manner. That's why electrons behave like a wave and a particle. This is all I want you to know, okay? هاي introductions للquantum mechanical model اللي هو أجدد موديل اللي حنشوفه يعني بعد شوي إن شاء الله. So just know that these are different things. Of course, de Broglie is a scientist. هذا عالم. You can search about him and and learn more about him. So this is Bohr's model, and this is de Broglie's model. Okay, it's like a wave. Electrons move like a wave around the nucleus, not just in a circular path. Okay. High concepts are rigid. These concepts are very hard to understand. So I'll try to simplify it as best as you can, because we can't see electrons with our eyes. We are just trying to model the atom from what we observe, like the light. So Bohr was very smart. Why? Because from these lines only he made the model of the atom to explain why these lines exist. Okay? So that's what we are doing with science. We see what's around us and then we try to make assumptions. نسوي فرضيات, نسوي نظريات, نسوي models عشان نفسر هاي الظواهر. Okay? So let's have a fun activity now. So imagine that this is a fan, مروحة, and this is blade A. So this is blade A, okay? And this is the second image. So this is stopping and this is moving, right? I want to ask you a question. Which image gives you the location of blade A? Image 1 or image 2? So can you know where is blade A here in image 2? No. It's image 1 because you can see it clearly here, right? It's not moving. It's not moving, right? Now my second question, which image tells you the speed of blade A? blade A here is not moving, it is moving here. So you can calculate the speed of the fan and then you will know. So it's image 2. Now I want you to think with yourself. Which image can tell you both the speed and location of blade A at the same time? So اختار صورة واحدة اللي تعطينا اللوكيشن وسرعة blade A في نفس الوقت. صورة واحدة. Is that possible? Because if you want to know the location of blade A, you need to stop the fan. So you will know the location, but you lose speed. And if you want to know the speed, you need to switch on the fan to move. So you will know the speed, but you will lose the location. صح ولا لا? So we can't from one thing. So this analogy we can apply. So blade A is like the electrons. Okay? Because that takes us to Heisenberg uncertainty principle. Okay? So what does it say? So it says the following. So he used de Broglie's model, like the model that the electrons are moving like a wave, to say the following. It is impossible to define or determine both speed and location of an electron at the same time. So if we want to know the location, we need to stop the electron because it's just moving. Okay? And if we want to know the speed, we cannot know where is the electron. So this is called Heisenberg uncertainty principle. Just know it like this, okay? Hopefully this analogy helped you a little bit to understand it, okay? Again, our main question now. The electrons are around the nucleus. However, where are they exactly? What's their location? What's the link of Google Maps that will tell us where are the electrons exactly? So, Schrödinger, which is a very famous scientist, he's behind the quantum mechanical theory, model of the atom. Okay, he used Bohr's model of energy levels, اللي هم energy levels, okay, N1, N2, N3, and so on. He used de Broglie's wave nature, where the electrons are moving like a wave, and he used Heisenberg uncertainty principle. You cannot define the location and speed at the same time. Okay? And he came up with the quantum mechanical model, which is the newest model of the atom. We describe the electron's location and energy. He said that the electrons are in a space called orbitals. So orbitals are the home of electrons. Okay? Al-aflak. Alright? So the quantum mechanical model describes the location and the energy of the electron, and electrons are in a space called orbitals. Alright? So what's an orbital? So what is an orbital? So the definition of an orbital is thought of as a region of space in which there is a high probability of finding an electron. Now this is going to be a little bit hard, okay, to grasp. Hopefully it will be easy. Hopefully. Imagine this is the nucleus, right? And I'm talking about the electron X. So that my electron, I'm going to call it X. So you might tell me that X is going to be here, صح? Or it might be here, or it might be here, or it might be here, or here, or here, or here, or here. So it's around the nucleus, right? لكن كم إلكترون أنا قاعد أرسم هني؟ هو نفس الإلكترون X، لكن هاي الأماكن المحتملة وين أقدر ألاقيه. هاي مش إلكترونات متنوعة، لا، هو نفس الإلكترون. قاعد أقول لكم أنا يمكن يكون هني أو هني أو هني أو هني أو هني أو هني أو هني or so on. So if I draw something like this, okay, and maybe like this here. Inside this circle, there is a 90% chance that you will find electron X. في هاي الدائرة هاي احتمال 90% انك تلاقي الالكترون X. هاي الدائرة كلها اللي هاي السبيس الفضاء هذا اللي فيه احتمال 90% اني احصل الكترون. This is called an orbital. So orbital, the definition of an orbital is actually a space or a region in which there is a high probability of finding an electron. The high probability meaning 90%. So this is the nucleus, right? هاي النقاط يا طلاب الأعزاء, these dots are actually only one electron. Sorry, it's not an electron, it's a possible location of an electron. Okay, so the dots are not an electron. These are possible locations of an electron. Like this one here, we can find it here, here, here. Locations, possible locations, أماكن محتملة. Okay, this is called the density map, which you have in your book. So if I draw a boundary here, you will find إنه في احتمالية أكبر إني أحصل إلكترونات داخل لأنه في نقاط كثيرة. فهذا الباوندري نسميه orbital that describes the location of an electron. Okay, hopefully you get it. You can repeat the video again and look at the explanation here. Okay, all right. So this is just a comparison between the quantum mechanical model and Bohrs model, which you can read on your own, and then you can try to compare and contrast between Bohrs model and the quantum mechanical model. All right, let's go and examine some of the true and false questions that we have here. So in the quantum mechanical model, electrons have specific or quantized energy. Yes, that is true. In the quantum mechanical model, electrons always have a specific amount of energy. Like Bohr's model, the quantum mechanical model does attempt to describe the path of electrons around the nucleus, and the answer is false. It does not talk about the path اللي هو المسار أو طريقة الحركة. It talks about the location, not the path. Okay, the location, not the path أو طريقة الحركة. The atomic orbital. Okay, so these are the atomic models. You can go to YouTube and watch videos about the atomic models. Okay, اللي تشرح لك تشرح لكم يعني كيف تطور atomic models. احنا في هاي الحصة تكلمنا على Bohr's model and the quantum mechanical model. Okay, ما تكلمنا على Rutherford or the cookies or the ball. All right, so you can watch these on your own. Now we are going to start the last part of this lesson. You can take a break whenever you want. Stop the video, go have a break, and then come back. Okay? Again, يا طلاب الأعزاء, all what we are trying to say here, we are trying to describe where is the electron. How can we describe the location of an electron? So we know that an electron is in a space around the nucleus. We call it an orbital, صح? But how can we describe this electron? Okay, so imagine you are ordering from طلبات. Maybe some of you use Uber Eats or I don't know, Kareem or whatever. Or let's stick with طلبات here. And the driver asked you for your location. This is the building that you live in. It's called Asiyad building. Block 5 أو المبنى رقم 5. Okay, and this is your apartment K. You live in apartment K. So how are you going to describe your location in the building? What are you going to say? So if you send him Google Maps, the driver will be down here or maybe at the door. Okay? So how can you describe for him to go from here and reach to you? So you will say, you need the building name, right? You need the block, you need the floor number, and you need the apartment number or apartment name or letter or whatever, right? So you will say Siad building, block 5, third floor, apartment K. صح ولا لا? So you used 4 things to describe your location. Okay? Now we actually, to describe, we need 4 types of information to describe an electron. So عشان نعرف اللوكيشن حق الالكترون نحتاج 4 أشياء نفس ما انتم سويتوا للدرايفر تبع طلبات. اعطينا له 4 معلومات عشان يعرف exactly where we are، صح؟ So we also need 4 types of information to describe the location of an electron. Okay? And now we move to the keywords. Quantum numbers. There are 4 numbers to describe the electron around the atom. اللي هي ال4 أشياء اللي قلت لكم عليها. We call it quantum numbers. If I say energy shell, I mean energy level. Energy subshell, energy sublevel. For example, energy level 1, sublevel 1.1. مثال, okay? This is what I mean by level and sublevel. Orbital, we already talked about it, a probable location of an electron, 90% chance to find an electron. Orbit اللي هو المسار الدائري. Do you remember? In Bohrs Model, orbit اللي هو المسار الدائري where the electrons move. So these, you will find me always talking about keywords because keywords are important عشان ما نتلخبط, okay? You will find these keywords in the book. Many of them you'll find in the book, or if you read online and so on. Okay. Again, we talked about orbital. It's a probable location of an electron. Okay. Now, let's talk about the quantum numbers. So to describe an electron's orbital or location, we focus on the 4 quantum numbers. One number gives us the size and the energy level of the orbital. يقولنا المبنى اللي ساكن فيه الإلكترون كم حجمه وشو طاقته. وبعدين the second number gives us the shape of the orbital. شو شكل هذا المبنى. Third number and fourth number we are not going to study, okay? We are only required to study the first 2. It gives us the 3D orientation here, and here it tells us if the electron is moving anti-clockwise or clockwise. يقولنا الإلكترون يتحرك بطريق مع عقارب الساعة أو عكس عقارب الساعة. Okay, so we are not going to cover these 2. We are only going to focus on the first 2. So we are going to focus on here the 4. We are going to focus on the principal quantum number and the secondary quantum number. Okay, هذه المعلومات ما عندكم في الكتاب. Okay, but I just, for your information, you can just focus on these 2. Okay, so the principal quantum number has the symbol n. احنا شفنا n قبل هيك. I'm gonna show you where. In Bohr's model, do you remember n? Let me go back. Yes, do you remember n? مش كنا نقول هاي اللي هي energy levels. Okay, this is the quantum number n, levels or energy levels, where the electrons move around the nucleus. So n we already covered before. So when I say n, think about these, okay? They are like energy levels. Okay, and it also gives you the size, the orbital size. Okay, the higher the number, the bigger the size and the higher the energy level. Now, secondary quantum number, we'll see it in the next slide. Okay, so these are the important information in your book. So the principal quantum number n اللي هو أول واحد. The principal quantum number n indicates the relative size and energy of the atomic orbitals. So الأوربيتال اللي هو اللوكيشن اللي الإلكترونات تعيش فيه، هذا الرقم يقول لي شو حجم هذا اللوكيشن وشو الانرجي تبع هاي اللوكيشن. As n increases, the orbital becomes larger. كل ما زادت n كل ما زاد حجم الأوربيتال. And the electron spends more time further from the nucleus. And يعني يصير يبعد الإلكترون يبعد من النواة. And the atom's energy increases. So n specifies the atom's major energy levels and also called principal energy levels اللي هم اللي شفناهم في بورز موديل N1 N2 N3. كل ما زاد ال N كل ما بعد الإلكترون عن النواة كل ما زادت طاقة الإلكترون. And the smallest principal energy level is assigned number 1. No zero. We don't have zero. We start only from 1. Okay? Now, if we think about the secondary quantum number, okay, it gives us, the shape of the orbital or the sublevels. So it gives us the shape. What is the shape of the orbital? احنا هني تكلمنا على حجم وطاقة الأوربيتال. الحين نتكلم على شكل الأوربيتال. Okay? Now we have 4 famous sublevels. We have 4 sublevels or subshells or shapes. Okay? So N is energy levels اللي هي 1 2 3 4 5 and so on. And S, P, D and F هذيلا are sub-levels. Okay? Now, the s orbitals, if you are an s orbital, your shape is going to be like a ball, like a sphere. نفس الكرة. If you are a p orbital, okay? If you are a p orbital, you'll be like a dumbbell or like number 8. هذا اللوكيشن. هاي النقاط يا شباب هي النقاط اللي قلت لكم عليها انه احتمالية نلاقي الكترون. وهاي هي النواة. Okay? Or the nucleus. This is the nucleus. This is the nucleus. This is the nucleus in the center, and so on. Okay? So, again, principal energy levels, they contain energy sublevels. Okay? Energy level 1 has only the S sublevel. Okay? So SPDF are the sublevels. Okay? الانرجي ليفل نمبر 1 فيها sublevels واحدة فقط. Energy level number 2 has 2 sublevels, S and P. Energy level number 3 has 3 sublevels, S, P and D. Energy level number 4 has 4 sublevels, S, P, D and F. I know this is very difficult to understand, but this is just showing you that the electron اللي يعيش في الطابق الأول عنده مكان واحد يعيش فيه اللي هو الS. الإلكترونات اللي تعيش في الطابق الثاني تقدر تعيش في شقة S or P. الثالث تقدر تعيش في S, P or D and so on. Okay? That's what I mean by sublevels. كأن هذا الطابق الأول وفيه شقق. الطابق الأول فيه شقة واحدة، الطابق الأول شقتين، الطابق الثالث 3، الطابق الرابع 4 شقق. Okay? كل شقة شكلها مختلف. And so on. So these are the energy sublevels S, P, D and F. So F has more energy than D, more energy than P, more energy than S. S is the lowest energy and F is the highest energy. And these are the shapes of S, P, D and F. قلنا ال S is like a sphere, like a ball. But this is 1s and this is 2s. What does it mean? It means here that the energy level is 1. Here the energy level is 2. شو الفرق ما بين هاي الصورة وهاي الصورة؟ تتذكروا احنا قلنا انه we said that energy level tells us about the size of the orbital. let's go back. The N tells us about the size and energy. So 2, so even though both are S, it means they have the same shape, Kura and Kura. But 2 means that 2S has a bigger energy and also bigger size. This is P, and this is D orbitals. Okay? So, you will notice here that in S, we have only one sphere. But in P, I have Px, Py, Pz. So if we think about it from here, S has one room. شقة S دايما فيها room واحدة. Okay? One room. شقة P has 3 rooms. This is what you saw here. 3 rooms. Okay? D has 5 rooms. That's why you see 5 d orbitals here. Okay? And F actually has 7 rooms. ما يهمني الطابق. أول ما أشوف ال S وال P وال D وال F, regardless of the level, the rooms are fixed. 1, 3, 5, and 7. Okay? We will see it here in this table. So these are the hydrogen's first 4 principal energy levels, meaning N equals 1, 2, 3, and 4. So again, remember, what is the sublevel type in energy level number 1? What's the sublevel? It's S, right? How many orbitals or rooms, here rooms are where electrons live. Okay? These are the orbitals. Okay? Where you will find an electron. Okay? How many did we say? 1 room. So only 1. What's the total number of orbitals related? So how many rooms can you find in energy level number 1? It is N square. So what is in here is 1. So 1 square equals 1. That's why if we go back here, you'll find that there is only 1 room in S, in energy level number 1. Now if we go back here, if we go back to energy level number 2, what are the sublevels we said? We said we have S and P. So how many orbitals are in S, or how many rooms? 1. And how many are in P? 3 rooms. So in total we have 4 rooms. صح? So the total number of orbitals in energy level number 2 is going to be 1 plus 3, which is 4. Or we can simply do n to the power of 2, اللي هي 2 تربيع يساوي 4. And so on. What are the sublevels in energy level 3? There are S, P, and D. How many orbitals? 1, 3, and 5. What's the total number of orbitals? It's going to be 8. It's going to be 9. Or we can say 3 square, which is 4. Number 4 is the same thing. We have S, P, D, and F. How did we know that? I told you about this when we were modeling the levels and sublevels and so on. Okay? We know the number of rooms in S, P, and D. It's 1, 3, 5. What about F? It's going to be 7, as I told you before. Add all of these. How much are you going to get? 16. Or you can directly say we have 4 to the power of 2. Okay? So, بس عشان أسهل عليكم. So, energy levels اللي هي N, these are like floors. نفس الطوابق في البيلدينج. Okay? Energy sublevels اللي هي ال S وال P وال D وال F, these are like apartments اللي هي الشقق اللي موجودة في الفلور. Okay, and orbitals are like rooms in the apartments, and electrons are people who live inside. Okay, so hopefully you can help visualize what I'm trying to talk about. So imagine that around the nucleus there are buildings where electrons live. Okay, so the floors are the energy levels اللي هي N1, 2, 3 and 4. energy sublevels are apartments اللي هم ال S وال P وال D وال F، وكل طابق فيه أنواع شقق معينة، وكل شقة اللي هي S, P and D and so on has different number of rooms. في شقة فيها غرفة، في شقة فيها 3 غرف. There are apartments that has 5 rooms and so on. And inside these rooms we have the electrons like people. Okay, so hopefully you managed to understand what I'm trying to talk about. So the rule says that one orbital or one room can hold a maximum of 2 electrons. نفس الغرفة الواحدة maximum يكون فيها شخصين. الأوربيتال الواحد can have 2 electrons only, a maximum. It can have 1 or 2, but the maximum is 2. Okay, so the number of orbitals in any energy level is equal to n to the power of 2. Example, energy level number 2 will have 4 orbitals, and I told you that one orbital can hold a maximum of 2 electrons. So what is the maximum number of electrons in any energy level? احنا نعرف انه عدد الغرف or the number of rooms is n to the power of 2 اللي هم الاوربيتالز، صح؟ هم الرooms. I am telling you that one room or one orbital can have a maximum of 2 electrons. So my question here, what's the maximum number of electrons in any energy level? So stop the video and come back to it. Okay, so the correct answer is 2n to the power of 2. ليش؟ لأن ال n to the power of 2 gives me number of orbitals، عدد الغرف، صح؟ And I know that one orbital can have 2 electrons، صح؟ So if I just multiply this by 2, I will get the number of electrons in n اللي هو الانرجي ليفل n. Okay, عادي يكون ال n 1 2 3 4 it doesn't matter. Okay, so these questions can come up in the exam sometimes. All right, and this is what we talked about. So the maximum number of electrons is 2n to the power of 2. So these are the hydrogen's first 4 principal energy levels اللي هم in 1, 2, 3 and 4. Okay, this is a summary of the levels, sublevels and orbitals. So imagine that the blue thing here is the energy level n. الطابق الثاني مثلا, this is n equals 2. الطابق الثاني inside في شقتين, شقة S بالأحمر هني وشقة P bigger than it, okay, اللي هي الانرجي sublevels SPDF, and inside الشقق في rooms. Inside this one we have 1 room, okay, and inside here we have 3 rooms. Okay, so these are the orbitals. Let's finish with this quiz. What is the lowest allowable energy state of an atom? So the lowest energy state is called excited quantum ground atomic. It's called the ground state. Okay, how many sublevels does principal energy level 3 contains? So n equals 3, so it has S, P and D sublevels, صح? So which answer is correct here? It's going to be number 3. And that's the end of module 4 lesson 2. I hope you benefited from this video. Please, if you have any questions, write in the comments, and again, please share the channel, the YouTube channel at Easy Chemistry for All. I am Mr. Muad. If you have any question, you know how to contact me, and I wish you all the best, and see you in the next video inshallah. بالتوفيق.